A few more examples on kind of visualizations. Again, this next one is from Tufte as well. And what it shows is enrollment at some college in California. And it looks at structure by age. And you can see the x-axis is just for various years. And here you have under 25 and 25 and older students um, at that community college or college. I don't know if it's a community college. So some university in California, you see how many students they have. On spatial substrate, obviously it's just linear axis, composition. Axes are actually shown in there. The marks, again, here you have two choices. You can say that each mark is 1 point represented here this way, and then they're connected by some kind of rounded lines, splines. And so that's one interpretation. And they also tend to have some sort of 3D. So maybe the marks itself is just one ridge here. And then you have a 2D surface, that kind of this 2D spline that moves around. Or you can say the whole thing is a three-dimensional shape. So this is one three-dimensional object that has kind of a complex shape. And here is the second three-dimensional object. So that's kind of the marks. They have colors. The top one is red and the bottom one is red and blue. Top one is green and yellow. And that's pretty much it. And they have a position or a shape if you consider it being one big line object. In terms of pre-attentive processing, probably if you close your eyes and open them, you kind of see those shapes pretty easily. You see the borders between the colors. That should be pre-attentively determined. So, and the 3D shape kind of tends to maybe make you remember the shapes there, just at a blink of an eye. Gestalt, there seems to be a little bit of symmetry. I'm not sure what it does. It creates some weird, actually, tension between these two symmetric shapes. And in terms of Tufte, data to ink ratio, it's pretty bad. Well, why do I even have to color this whole thing? Why do I have to color this? Why, first of all, why do I need the 3D part? Okay, so you can say data to ink ratio is really bad. Chart junk, the 3D part, you can consider it chart junk. Or you can say, oh, that's really good. Many times, actually, let me go back for one little second. If you go to the principles here, many times you have a choice between multifunctioning and chart junk. You would have some people who say that certain thing is chart junk, and other people will say, no, this is multifunctioning. It has a design function. Look how beautiful the visualization is. I'll have some example later. But on the most part, they cannot be both bad on some visualization. You cannot ignore them both. So you either say it's multifunctioning elements because it represents data, but it also shows something else, has an artistic function. Or you say, I don't care about the artistic function, and it's therefore chart junk. But you cannot say they both don't exist, because some visualizations do have something in there that, like this one, for example. So that 3D thing, you can say it's chart junk, it takes a lot of space, or you can say, no, it actually has some sort of artistic feature, so maybe multifunctioning in the 3D space. Well, Tufte thinks it's chart junk. Actually, he goes ahead and says, how many data points are we actually displaying? 5. The answer is 5. We have one here, one here, one here, one here, one here. So all that ink to just display 5 data points. Why? Because the other ones is the complementary. Obviously, you have this many students, 25 and older. By definition, everybody else is going to be the other 100%, whatever is the complementary part, is going to be under 25, period. So really only 5 data points are expressed in this visualization. So it's just data to ink ratio is horrible. Next one, it shows something about a newspaper, how many articles they had covering. So you can see percent of critical articles on INF, which stands for inflation. And there were 415 articles about inflation, and the percentages, you can see about 30% were critical, and so forth. So you kind of see it here. It's a bar chart. Spatial substrate, again, 2 axes, composition, linear. Each individual bar is an object. Okay, and on properties, they have obviously an X position. They're placed somewhere on the X axis, left or right. They have a height, and they have a shading and a label. So those are their attributes. I don't know, Gestalt, I can't think of anything on this one. And then on pre-attentive, you could probably determine this area pre-attentively. You know, the difference between when kind of the rough shape of the graph, of the edges of the graph. Tufte principle, what do you think? Data to ink ratio. Hmm? Oh, no, it has nothing to do with it. No. It's not colored. It's how much ink. Well, actually, Tufte completely hates the hashing. He calls it a vibrating design. So he says it's chart junk. So it vibrates so badly that it creates kind of, it's like chart junk. And you don't need it. You can take it out altogether. Talking about data to ink ratio is not also great. Why? Because I have that junk in there. This whole thing is also charge junk. They used the vibrating hashes to use them as a legend here, but you don't need it. You can say inflation right here, and you can say unemployment, maybe like that, a little bit at a 60-degree angle or so, and have it there perfectly fine. So you can get rid of this entire thing. And then if you want the number of articles, he suggests you just put them in here, say 450, or put it right on top of each bar. How many articles were on that, or at the bottom, it doesn't matter. The bottom part less confusing. So you have the same information, but you have a lot of chart junk. So that's, again, this is Tufte's one. So those were the example from Tufte. And these are, I found somebody else asking questions about visualization. When you look at one or your visualization, so this is not Tufte principle, it's Marty Hurst, but what does it teach, show, answer? What is the key contribution in a sense? What's new on this visualization, or I've seen it before, is just a bar chart, and that's it. So that will be kind of what is new in that visualization. Are there some useful examples of it? So is there a data set that works really well with this, and others may not work that well, but there are some. Have they done usability studies? And then you can ask about Tufte, Gestalt, visual structure. Okay, the next ones are mine. I used to have homework ones. Students would just find interesting visualization, interesting really good or interesting really bad, and kind of have to submit and comment on them a little bit, but that's kind of past. Visualization now is everywhere, like I said. That's not a task anymore. They're all over the place, and most of them are good, so it's kind of hard to find bad ones this day and age. So these are some ones that people found, and I just kind of point out they have different interesting features that I want to point out. This one, in terms of spatial, it's something about music. If you read them, there's artists. And there are some lines, but I'm not sure why. This seems like a circle, or maybe it's not a circle, maybe it's 2 links. Anyway. So spatial substrate, I think it's interesting in the sense that there is no X and Y axis at all. Those things are just in there. It's not like they represent anything. And then marks are each individual circle. So a mark is a circle. And they're linked by some lines. So marks do have, they have a position, but it doesn't signify, it has no meaning. So I wouldn't even say that that is part of the data. They're only representing data by size and color and label. There's a label of the artist on them. So that's all they have. And then they're connected. In terms of Gestalt, I don't see much. Pre-attentive, not much. Maybe you'll be able to kind of detect the two big green blobs in the middle, but you're not going to get a lot of data pre-attentively. Tafti principles, data to ink ratio, maybe a little bit high because if I don't fill in the circles, maybe it's better. Chartjunk, possibly. I mean, the circle have this weird lighting on them. That may be distracting. I'm not sure if it adds much to the, but maybe it adds. I don't know. It's up to you. Multifunctioning graphical elements, and here is no. I mean, those circles are just circles. Okay, so it's not multifunctioning. They do have a color, they do have a size and a position, but that's not that's a normal circle. Okay, so that's an example of where people used to say, oh, this is multifunctioning. No. It's just a normal function. They don't work together. They have no design. Even the 3D power, the lighting thing, it's not really artistic. It's not doing much. So it's not multifunctioning. How about small multiples? And again, somebody pointed out, well, what if is one circle one multiple? No. It's not a visualization by itself. Here's an example. It would be a visualization if one circle, let's say, was a pie chart. Then yeah, that's a visualization by itself. If I have a bunch of pie charts in a visualization, then yes, I have small multiples right there. But this is just a circle, so it's not a small multiple. It's not that I have multiple visualizations. Yes, I have multiple circles, but all visualization are going to have multiple graphical objects in them. It's not just one object. Causality, no. In the end, I think it's not a really good visualization. And even the lines, they don't tell you much. The colors, maybe they have a meaning, but it's not obvious from this. This is kind of an example. Sometimes they call it a theme river. I mentioned it when we're looking at mountains of topics, like from CNN. So that's a theme river. That's kind of you can look at topics, how they evolve over time. So in this case, it's what Americans do, I think. That was from New York Times. If you search for it, you may still find it. You can actually, this is what everyone is doing. So notice here, one of the rivers, it almost feels like it's the background. It's sleeping. So most people sleep at night. Some do sleep during the day. And then we go back at night. You can see they're going to go to work. That's the river for the work. And you can see kind of, at some point, they stop going to work and go eating. That's lunch. Here is dinner. So there's more people do lunch at the same time. People tend to kind of space out the dinner. They don't work that much and so forth. So you can see there, why do I have, one interesting thing about this, it's generally considered a good type of visualization. But if you look at data to ink ratio, it's really, I mean, I'm using almost each and every pixel to display something. Bing, bing. So data to ink ratio is awful, yet this is a good visualization. So this is an example where I can have good visualizations that break Tafti principle, but I just need to know it. And so now back kind of doing the whole analysis visual. I have two axes. This is percentage. This is time of day, kind of going on the x-axis. So it's again composition, linear axis. That's it. Marks, and again you can see a mark as one bar pixel for each time. So this would be the bar for work, and then it's put on top of the bar for whatever the other one is. And it's poor bar for, they kind of, you stack all these bars on top of each other to obtain the river, and you repeat that. So, and then if you consider that as bars, that each bar has a length and has a x position and it has a color. And they're staying next to each other. So that's one. The other view, like I said, you see this as an iso surface, and you say that this whole work thing is just an isosurface that has this very complex shape. It has a color and it has a complex shape. Either way, I think it's good. They both cover it. In terms of Gestalt, I don't see much. Pre-attentive, yes, you can probably pre-attentively determine the big blobs in here. You can probably determine this and maybe the work kind of sitting in there, the shape pre-attentively. But other than that, you have to read and figure out what they are. And again, Tufte's principle, I already kind of started. It does not do a good job at data to ink ratio because it uses each and every pixel, but it's considered a good visualization. Typically, people use it. You'll find it. And ChartJunk, not ChartJunk, nothing that kind of to annoy you in the visualization. It's not there. Not like the previous, like the one with the articles in the newspaper that was vibrating, all that bar chart. So no, ChartJunk. Does it show time? Yes, it has time on the bottom. So technically, it does show time. Does it use small multiples? No. Multifunctioning graphical elements. Here you can make a case that if you look at stacking all of these, you can kind of see activities that are not sleep, but it's kind of a weaker point. Then you can maybe follow the river left and right, just a little bit like we've done with the divisions, U.S. divisions in World War I, but it's not as strong as that. So I don't think it's a weaker case for it. So that's my analysis on this. Keep going next. This one, it's browsers. It's interesting so let me explain. There's an axis, and I think it's 2002 here. Let me get black. 2002 is here and 2009 is here. So popularity of various browsers. So there is one axis that goes this way. And then the other axis is round. That's linear. And then it's composed. They're still using composition. It's composed with a round axis. Kind of keeps going in a circular way. Okay, so other than that, it's a bar chart. It's a bar chart that has a kind of a weird round axis in the middle. So then you have stacked bars. You have Internet Explorer, Mozilla, Firefox, whatever, Chrome, whatever is there. I can't read. So it typically, like I say, each of these is a bar, and it's stacked on top of it. So our graphical elements, graphical objects are going to, or marks, are going to be bars, but they're curved. They're stacked on top of each other. So each bar is stacked on top of the previous bar, or it starts from the bottom, and it has a length. And the width is fixed, and it has a color. Yes?
This is like so completely unnecessary. I just make a stack bar. Why make myself so
Yeah, and maybe this is one point where if you look at the visual, the spatial substrate, you realize there's a, why are we using a round axis? And just thinking that is like, I can make this better now. I know how to, what if I just do it normally with a linear axis? How would that look like? Okay, so that's one point. I think it's interesting because you see it kind of different kind of axis. It's round. Why is it hard? It's really hard to compare. I told you it's hard to compare stacked bars in general, But stack bars that are curved at different radii, it's even worse. So for example, is the length of this blue bar here the same? How does it compare with the length of this one here? That's really shorter there. So it's almost impossible to compare them, especially the ones that are really close. You can pick something that's a little bit shorter. So let's say something that's really close to the edge. How is that comparing to the green one here? Which one is larger? You can't tell. The differences need to be really large for you to be able to tell. So that's maybe the drawback of this round layout. Pre-attentively, you can determine obviously, I think the blue and the brown, they kind of make a good, and then the round thing in there, I don't see there's anything Gestalt-wise. Tafti principles, data to ink ratio is not great, but I'm not sure. It's a bar chart stacked, so it's kind of, it is what it is. Chart junk, you already made your point that this is chart junk because they kind of rounded it out and it makes it worse. Now, if I go to multifunctioning graphical elements, I can make so some people will agree with you. Some people may agree with what I say next. Yes, it shows the data about browsers and their usage, their popularity. But also, if you, I'll zoom out a bit. If you look at it from a little bit further away, do you recognize something there? I will share my screen a little bit later, but if you want to look at your Firefox icon, it looks like the Firefox, a lot like the Firefox icon. So if you recognize that, and people who love Firefox say, oh, that's artistic then. All of those have a multifunctioning element. Not only that I have the bar chart showing the bars, but now they together form the Firefox logo. So here, like I said, here you have to pick. It's either junk or it's artistic, therefore multifunctioning. But you cannot ignore it. One or the other. And that's pretty much it. I don't have any small multiples. It's just a single visualization. And time is, again, technically is built in there, but they don't do anything much more to show cause, effect, or anything like that. So it's kind of the letter of the principle, but it's not the principle of the principle, the intent. Couple more. This one, a lot of, you'll see these in terms of infographics. And again, Tafti principle-wise, you run into the same issue. Is this chart junk? Or is it something kind of to get the user involved and therefore it's multifunctioning elements? Not only they show data, but they get an engagement from the user. So one or the other. Other than that, the other thing interesting here is that the visualization has been, it's partitioned into smaller things. It's not that obvious it's small multiples, but I could buy that argument. That each of these, it compares a stadium, maybe Dallas Cowboys stadium, old stadium versus new one. And as you can see here, they have 22 more escalators, 22 versus 9 escalators. Here is how many elevators they have. And they use kind of an elevator icon for it. They use an escalator icon. So you can say those are chart junk. Or you can say, no, they're artistic because they kind of show you what it is. It's the escalators. This is the cost. I think it was pretty expensive. And here's the capacity in terms of people and temperature, in medium temperature inside, and I'm not sure what else is, concession stands. So all those big numbers, you can say charge junk and you're destroying data ink ratio, or you're saying it's multifunctioning element. Although I'm not sure how multifunctioning this thing is, but what's the other function of it? So it seems to be a lot charge junky. So again, visual structure, they kind of partition the space into some weird parts, but there are no axes otherwise. It's always next to each other comparison. If you want, that's a little bit of Gestalt. The fact they're next to each other, you compare them and you assume they go together. So these numbers, you assume that these two numbers go together and they don't overlap with those numbers. So that there's a little bit of Gestalt at play there. Each graphical element object is different. Some of them are elevators, some of them are really big text, some of them are cubes. So it's kind of a weird area. They have a size and they have a color. And that's what you see in there. So that's pretty much it. I covered Tufte. There's no, if you say there is multifunction elements, maybe these, because they kind of show there's an elevator. But the other ones, just pure text, I don't know if that is multifunctioning. I'm more inclined to say chart junk on this one. Data to ink ratio, not that great also, but it's there. So like I said, there's a whole subclass, or some people say it's a completely different thing than information visualization. It's called infographics, so things that you display more to elicit a response, an emotional response from people rather than to allow data exploration and analysis. And it's good. I mean, that's a whole field. They work. So Gapminder word chart, and this is kind of an interesting, you can search for it. You may have run into it. I think for a while it was famous. But first of all, it allows you to kind of put more than one variable in here. So let me see. So money, the x-axis is money. The y-axis is health. Children dying before age of 5, and here is gross national income per capita, things like those. You can see that there is a correlation. First of all, it's a scatter plot, so it tends to be that the more per capita you have, the better. There are some countries that are kind of have very low death rate and they don't have that much money, so there's whatever those are, you can kind of see them there. So besides these two axes, that again, spaces, composition, linear axis, then each mark is one circle. And that's it. So I've had people who said that each mark here is multifunctioning, but it's not. It's just a circle. It does have an X and a Y position. It has a color, and it has a size, and it has a label, and that's it. But all circles will do that, or most normal circles do that. There's nothing else than that in there. And they're colored by the continent. I think red is going to be Asia and so forth. You kind of see them. And then the population, since China and India are the biggest, so that'll be population-wise. That's the size. Preattentively, I would think that you would see this blob in here, the red one. Plus, I read in an article, and again, it was an article in IEEE, so it was an engineering journal or an engineering publication. But they said that our eyes apparently has more receptors for red and green, and fewer for blue. So we tend to focus, if you have a lot of red, then you would tend to focus on that first, and greens. In this case, there's a lot of red. So preattentively, may be able to see the blobs in the middle, and that's it. Gestalt, not much. And Tufte principle, maybe this is one of those where I don't see any Tufte principle being either employed or violated. It's kind of, all of them are in the middle. Chart junk, not that much. Data to ink ratio is okay, not great, but it's not spectacular one or the other. Multifunction elements, no, and that's why I want to point out it's not. Yes, each circle is a circle, but it's a circle. It's not doing anything else than being a circle. Yes, go ahead.
So the color of the circle and the size of the circle is multifunction.
That's not a multifunction. That's what I'm trying to point out. That's a normal, any circle you draw is going to have a color and a size. You cannot draw it without a color and a size.
In the last one, the color didn't matter, but here the color says Asia.
Yes, and you can vary the color. And just like you have a rectangle and you can vary the length and the width of the rectangle, But that's just a data attribute. It's not multifunctioning. It's not.
It's not like a pie chart.
It's not something out of the ordinary. Oh, a pie chart still not going to make it multifunctioning. So let me say that again. A pie chart is not going to make it multifunctioning. It's going to make it a small multiple. The pie chart becomes one visualization, and then you repeat the pie chart, so you have small multiples, small visualizations being repeated. That's true about pie charts instead of circles, but still not going to be multifunctioning. It's multifunctioning when they work together to give you more information that a normal circle will do. And these, they don't. They just sit there.
Each attribute is giving a different information.
Yes.
So can we not say that it is giving more information, so it must be?
No. And again, the reason is that it's normal for a circle. You can use color to do something with it. You can use radius to do to encode a data value. You can use its position to encode a data value. That's just normal encoding of a circle. It's nothing out of the ordinary. Now, if this circle works with another circle and they create something, here's an example of multifunctioning. Each bar is a bar. It has a color and it has a length. If you want to add labels and stuff to it, that's fine, you can do it. But they work together. So each bar contributes a little bit. Each bar contributes a little bit. This one contributes a little bit to form the big Firefox picture. So they work together. That's their other function. It's not normal for them to form a Firefox for a bar chart. If you pick 100 bar charts, you find other numbers, they're not going to have a Firefox in there.
Can I ask a question here, please?
Yes, go ahead.
Yeah. The fact that this circle is conveying the picture of Firefox, it doesn't have anything to do with the information that is to be conveyed regarding the usage, the percentage that browser is being used. So it may be something like artistic than conveying another information on top of that, right? That's where I just get confused.
So multifunctioning can happen two ways. They convey both data and have a design function. So the design was the Firefox. So it falls under number one here. Or they show different pieces of data. That's not normal. So here is the example of here showing different pieces. So this number here not only shows me the label for that division, but it works with all these other ones to form the bar, and it works with all the other ones to show me how long they've been there and when they've. And it actually works even with the label here to show me when they've been there. So that's not normal for a label to work like that. You know, many times when it's multifunctional, they kind of work together with some other elements in the visualization to kind of expand it beyond. But if I have one label here, here's another example of a label. This label is not multifunction. It's just a label. It sits there. It's not working with anything to create anything else. That's my point that I want to make. So same thing with, if I were to represent this by circles, they're not going to make them and make their size different somehow. It's not like the circle is multifunctioning because it shows multiple pieces. If it shows multiple pieces by the circle itself not working with with everyone else, it's not multifunctioning. It's a property of the circle that I'm varying. And that's it. I mean, I could go back and change the color of the label, but a label can have a color. So it's, again, I'm not multifunctioning that label. I'm just adding a color to it or using the color to represent one data attribute. So if it's normal, if it's part of the circle or part of the label or part of the rectangle, then it is not multifunctioning. And like I said, many, many times they work with other pieces of the visualization to come up with either some design issues or some artistic issues, some to convey something, or to convey more patterns about the data. You still want to? Yeah. Okay. And that's why really I have this picture here, because that was a good discussion. Thank you. Because here, yes, each circle conveys the money, the health, continent, size of the population. So it has, and the label, the name of the country. So it has 5 things that is, but that's normal for a circle. It's not, if I take this circle, put another visualization, it's still going to convey those 5 things. Okay, so it needs to be unusual, and it needs to, many times that unusual thing happens in concert with other things in the visualization. Sometimes it may be the background of visualization that gets it, but 9% of the time it's going to be other data elements in the visualization. So kind of that's what I try to kind of help you critique a visualization and introduce Tufte and kind of put together. This whole lecture 2 is for you to look with the more, if you want, technical eye. And again, it's a soft science. The technical part is not hard mathematics or anything like that. But at least you can look at it, at visualizations, a little bit more critically. And so you know it's coming. It's not going to help you that much, and this may be the only time I'm doing it, hopefully, this semester. Next week, I'll have a homework more on Tufte. Well, part of it will be on Tufte, part of it will be building visualization. So it may be the only time we overlap the review. I'll try to, well, it may be, may not, but I'm not going to overlap it many times. I think most of the time I go slow enough that I don't have enough material for you to give you the next homework. But this time I already covered Tufte and all of this, so we will look at the next kind of homework.